Hello everyone and welcome back to Small Brain Productions. So I have a few things I want to share today. The first thing is a math question. So let me just pull the action up. So this math question was given to me by my friend who's currently in university. He doesn't have the answer, or he didn't share the answer. So I don't know if I got it right, but it's a possible solution, and I want to share how I got it today because I think it was pretty cool. So here's how the question goes. Let me just write it down as well so you can see it if you want. So so you have the number n. Okay, wait, let me just. You have the natural number n. So what a natural number is, it's a number that you'll eventually reach when you're counting. So you would have no decimals, you have no negative numbers, and 0 doesn't count either, I'm pretty sure, because I think that counts as a whole number, and you don't count 0 when you are counting up, unless you're coding, of course. But we're not coding here, so it doesn't count. So you have a natural number n. The last digit is 6. I think you can tell what that means. And when multiplying number by 4, when you multiply the number n, just in parentheses, you get the same number as when you move the 6 to the front. So this is basically what it means. This is not a solution to the problem, but I'm just doing it to show what it means. So basically you have this number over here, and when you move the 6 to the front, the very front, it becomes 6, 1, 2. And basically what you want to do is have this number multiplied by 4 be equal to that number. So I thought this was pretty cool, which is why I am sharing it today. So I already solved it. I have it on paper next here, and it's pretty neat actually, a lot neater than what I'll be able to write here. But yeah, here we go. So this is the first thing that I did. Well, not actually the first thing. It was the first productive thing that I did, because when I started, it was just messing around and hoping it worked out, which it didn't until I messed around enough and stumbled upon something that would actually work. So this is the first thing that I noticed. When I move 6 to the front, the number at the very front becomes 6. So that means the number would be 6, 0, 0, 0, whatever, and it keeps going, obviously, or 6, 9, 9, 9, whatever. And then what this tells me is, in order to have this number, in order to have 4n equal this number, n would have to be this number divided by 4, which is 1500, whatever, or 17500, whatever. So what this tells me is n has to be within 1500, whatever, and 17500, whatever. What this also told me was, because I'm moving 6 to the front and every digit shifts back one place, it would become 615, whatever, to 6175, whatever. So what this tells me is I can even further shorten this down, shrink down the bounds by dividing these by 4 as well. So let me use my calculator. It would be 15375 to that doesn't seem right. All right, I forgot the 6. To 15375. So the starting number, the starting digits of n must be between these two numbers. Okay, let me delete this stuff. So that's the first thing, first productive thing that I got to. The next thing was, I realized that in order to have the numbers when they're multiplied by 4, in order to have what am I saying? In order to have number n equal number 4n when it's multiplied by 4, how do I word this properly? Okay, let me see what I wrote here. We are also provided that with the information that when 6 moves to the front, every digit shifts down. So we need to ensure that the new number in the nth position is equal to the previous number in that position multiplied by 4. Okay, I think that's even a worse explanation. Okay, let me see if I can explain this a bit better. So you have number 156. Man, what was I writing? Okay, I don't even know. I don't know like how I made sense when I wrote that, but that was what I was thinking at the time. So you have this number, and when this number gets moved to the front, it becomes 612. And in order for this number to be equal to this number, it would have to be multiplied by 4. So you would have 504. And because everything gets shifts down when this happens, this digit over here would have to be a 4. This digit over here would have to be a 0. And obviously that would have to be a 5. But in order to have this shifted down by one place, it would have to be equal to the number that's created and multiplied by 4. Well, that's an even worse explanation. Okay, I'm just going to do the question, and hopefully it makes a bit more sense. So this is what I did. So we have 6. 6 multiplied by 4 is 24. So you would have carry the 2. It's over there. And then you have 4 times 4, which is 16. You add in the 2, and that gets you 18. You carry the 1. Multiplied by 4, and that gets you 9. You have this multiplied by 4. That is 36. Wait a second. Okay, small miscalculation, technical difficulties. 4 times 4 is 18. Well, plus 2 is 18. Carry the 1. 4 times 8 is 32. So you have 3 over here. You carry the 3. And then you have times 4. Times 4 is 12, 15. Okay, so one thing you'll notice here, let me just put down the 1. One thing you'll notice here is 15384 is, in fact, within these bounds. So this is the solution that I came up with for this this problem. It satisfies both of the conditions in which when it's multiplied by 4, the numbers that shift down take its place. So you can see here, let me like... No. Get that 4 too. Oh wait, I can't shrink it. How do I get a new page? Okay, I'm just gonna try and stuff that there. Oh, adjust size. There we go. Nice. Okay, what was I talking about again? Oh right, yeah. So when you have the number 1538446. Oh right, and also you're searching for the smallest natural number. Yeah. So this number over here, it like repeats after a while. So technically you could go on forever, but because we're looking for the smallest natural number, we want it to have as few digits as possible. So you have this number here, and when you move the 6 to the front, it becomes this number. And this number over here multiplied by 4, you know what that gets you? I'm using a calculator. It gets you this number. Wow. Let me just verify that real quick. Yeah, it does. Wow. So it gets you that number. And I think this can this better illustrates my point. If I just shift this over by one place, you can see that all of these link up. So this one, the 6 moves to the front, but these numbers are all the same. This is because when they shift back, they have to be equal to the number when the 6 is at the front. Yeah, I think that makes sense. Yeah, so that is the math question that I found pretty interesting. I think my explanation was pretty garbage. I don't know if I'm not sure if this is like the correct way to solve it. I'm sure there's like a way to solve it a lot faster because I'm not like a great math person. But that is the way I solved it. If you have like your particular way of solving it, I'd be really interested to see that in the comments. Yeah, so thanks for watching. And yeah, that's all I have for today. Oh, wait. Right. And this is the other thing I wanted to show you guys. I was in Toronto, so the University of Toronto, and I saw this pretty cool pigeon walking. That's it. Goodbye.